Central angle. So we're gonna, as we progress through this chapter, things will get a little confusing because sometimes we'll talk about angles, sometimes we'll talk about parts of the circle, and we'll also talk about angles that have their vertices located all over the place. Mainly the center, inside, on, and outside. So this can get a little tricky. We're going to start with the most basic, which is called a central angle. Any guess what a central angle is associated with a circle? Jalen?
The angle that is made by the center.
Can you be more specific? Where's the vertex?
The vertex is the center.
Good. Do you know that symbol?
No.
That's a theta.
Wait, then what's omega?
What's omega?
That's fishy.
Capital or lowercase?
Both.
Capital.
Capital is the thing in Batman versus Superman, that big thing that was carved in the sand. That's an omega.
I don't know that.
Lowercase looks like a W with a tumor.
Oh, yeah, with the big W.
Why do I know them? Two reasons. I have a degree in science where we use all of those, and I was in a fraternity.
What fraternity were you in?
No, I didn't. No, right. I was sitting around deciding, do I want to watch a movie, do I want to kill someone, or do I want to learn the Greek alphabet? And one day I opted for the Greek alphabet. Someone out there is very thankful for that.
I thought you said you wanted to cut that part out. Of
Part of what?
You just exposed yourself. When you
Wait,
said
are, like-
you were a serial killer.
All right, so Jalen pretty much nailed it on the head. It's a circle. Sorry, it's a angle whose vertex is at the center of the circle. Therefore, the sides of the angle are radius. Radii, sorry. Octopus, octopi. Theta is a fairly common Greek letter that's used to represent angle measures in pictures. In math and in science. Okay, good. Next on the agenda, what's an arc?
Obtuse.
I'm sorry?
Is it obtuse?
There are obtuse arcs, yes, we'll get to that later. But we don't know what an arc is yet.
The side that would be the longest part of
Did you use the word side with a circle?
the curve.
The curve.
In between, like, not the vertex, but the other 2 points.
These 2 points.
The curve connected.
This thing.
Yes.
Okay, that's good, but you still haven't defined it. Yes, you're correct, that is an arc, but what is it? If I was trying to describe an arc to a blind person, I couldn't hold my fingers up there and go, see this thing here.
That'd be
So mean.
Anybody else? That's what one looks like, by the way.
Well, they're like
Haley.
Is it part of the circumference? I don't.
You're overthinking it. Sarah.
Is it the opposite angle of the vertex?
That's what I was gonna say.
Mhm.
It's,
up.
well, I mean, it's a line
No, it's not.
that, it's a
Curve.
curve that falls on the circle connecting the 2 points.
That's actually
Go ahead.
That falls on the circumference of the circle.
It's the same.
What do you got?
I don't remember what the end points of an angle are.
Angles don't have endpoints. Remember, by definition, angles go on forever, they're raised.
Never mind.
You guys are overthinking this. It's just a chunk of a circle. Great. Natalie, you were closest by far.
Okay.
Yeah,
Good job. Thanks.
that's it. Hey, you can get all fancy and you can talk about it's a set of points on a circle such that they lie between 2 points on this, blah, 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 blah. It's just a piece of a circle. Yeah, that's it. So there are 3 types of arcs that we're going to deal with: minor, major, and semicircle. Okay. Minor arcs are arcs that are measured, whose measures are less than 180. So you're asking yourself, how do we measure an arc? Want to guess? For instance, How big do you figure that arc is? Approximately. How about that arc? How big is this green arc?
Like
360.
160.
How much?
112.
Nope. Oh wait, which one?
120.
This 112 or this 112?
Oh, I think you meant. Could you do the hypotenuse or something with the hypotenuse?
What hypotenuse?
Oh, never mind.
I mean,
The like
it's still
largest,
bigger than 90.
the largest size.
Correct.
Yeah.
Wait, but you can't really use this because there's two arcs. So how are you gonna know which one you're talking about?
Is it 360? Because it's a circle.
There is
Oh,
two
don't
arcs.
wait.
Oh,
Stop
thank you,
waiting.
thank you.
Is it 360?
This is 360, yes.
Okay, yeah.
So how big is that? Whoops. How big is that? Just looking for a ballpark here. We're just trying to establish how we're going to measure arcs.
120.
112.
Why?
Just
One-
because.
Because
It
it's
looks
more than like
different
a
than
quarter
that.
circle.
112.6.
If you think of a circle,
It looks a
it's-
third
it's
more.
Hold
less
on,
than
I'm thinking of a
Don't
circle.
you have to?
Okay, I got it.
120.
Don't
It's
you have
less
to know what
than-
the
Yeah,
whole
120,
circumference is to know what the arc is?
Ooh, that's something different. That's arc length, which we'll get to later. We're doing arc measure first.
What's
I was just going to ask the same question. What's the difference?
yeah?
Yeah. I'll tell you that this is about 112, 120 degree arc. But where did that number come from?
It's about a third more than 90.
It's about a third of the circle, and
It's just greater
360
than
divided by 3.
Oh yeah, how many measurements are in the circle? Or in how many? Yeah, it's a whole circle.
How many
Degrees.
degrees are in the whole circle? Right, so that explains this being 360. But why is that 120, let's say 112, 120? Yeah,
It's about a third of the circle. So you take 360 divided by 3, and you get about 20.
okay, not horrible. Well, we'll come back to that in a second. 3 of them, minor, major, and semicircle. Minor arcs have less than 180, major arcs are greater than 180, which is weird because that's the first time we've talked about any angle that has a measure greater than 180 degrees. Up until this point, there was never any such thing. Now all of a sudden we've got something that's greater than 180 degrees, and a semicircle is just that, it's half of a circle, measures 180 degrees. Okay, where do those numbers come from? The measurement of the arc is the same as a measurement of the central angle. So if I go back to this guy, the measurement of this arc is equal to, anybody know what symbol that is?
Beta.
That's a beta, correct. Is equal to the measurement of angle beta. So if angle beta is about 112 degrees, then the arc is 112 degrees. And again, that's arc measure, not arc length. Arc length comes later.
Wait,
Whoops.
can we see that?
That's okay. The other thing to make note of, we've got 2 letters representing a minor arc, 3 letters representing a major arc. There's a reason for that in a second. Semicircle, even though I didn't list it there, you also need 3 letters for a semicircle. Natalie, question?
Just to clarify, so you said that the degree, like the central angle, is the same thing as the arc.
Arc measure, yes.
Okay.
Go.
Is this just like a question? The Greek-
As opposed to a statement, or a quandary, if you will,
Yeah, yeah.
or a hypothesis,
Alright. For the Greek.
or an enigma,
Yeah.
Okay.
I don't know what that is, but yeah.
sorry, a conundrum, if you will.
Yeah, sure.
Okay, great.
For the Greek alphabet, do you like write English words just in the Greek letters?
No, you write Greek words in the Greek alphabet.
What are you?
Why would we?
Yeah, that.
Well, the alphabet is fairly similar. There you have 24, we have 26, so a beta is kind of like a B, and alpha is kind of like an A, but it does break down because Greek goes alphabetic gamma, and we don't have a gamma. We've got a C. And we got 2 extra flows in there.
I have no idea.
Right out English word basically.
Well, actually, there are some that are identical. A capital A looks just like a capital alpha. Some of them are funky, like that's lowercase beta, it looks like a B with a tail. But then there's other ones like phi and psi that look nothing like. Then there's others like, there's other like capital gammas look like upside down L's.
How are the sounds
Okay. Okay, so that's what we said already, right?
Yeah.
Now, the reason why we use 2 versus 3 letters depending on the arc is, if I'm talking about a minor arc, that means go from the 2 points as quickly as possible. So if I'm talking about the minor arc AB, I would put AB with an arc symbol over it. That means go from A to B as quickly as possible. If it has 3 letters, I think this might be on the next slide, but I might be jumping the gun a little bit. That means go from, let's say we have put a point over here called C. If I have the arc ACB, that means go from A to B, but pass through C on the way there. Okay, so we have to have a way to denote which way you go around the circle. Do you go the quick route, or do you take the long way home? Semicircle, we also use 3 because even though it's the same distance, you need to know, am I going along that part of the semicircle or that part of the, you go on the top or the bottom, the left or the right. Arc length, okay, wait, are we good on that before I move on? Because now we're going to shift gears from an arc measure to an arc length. Okay, we're good?
Yep.
We got that. All right. Next, talk about arc length. That's now a distance. And so, playing off what somebody said before about that arc that I showed you was about 1/3 of the circle, we're going to use that to find the arc length. And I already flashed it up there, so you could use this. And what does this mean? You take the measurement of the arc in degrees and put it over 360. This will generate a ratio. In other words, what ratio of the circle are we talking about? What proportion of the circle are we talking about? What percentage of the circle are we talking about? And then multiply that by the circumference. So we'll end up calculating what part of the circumference do we have. Again, AM is arc measure, AL is arc length. Natalie?
So could you have the symbol pi in your answer for arc length?
Yeah. Whereas arc measure is just degrees. Okay, we good so far?
See.
Don't get those two things confused. Arc measure is degrees, arc length is a distance. This doesn't come up a lot, but what do you think adjacent arcs are?
They equal 360.
What's that, Matt?
They equal 360.
Don't have to. Kind of a smart aleck answer, but it works. There are arcs that are adjacent. What does it mean to be adjacent?
Yes.
They're arcs next
Arcs
to
that
each
are
other.
right next to each other. Ooh.
There's a fancy math definition. But like you said, there are arcs that are right next to each other. Share a common endpoint on the same circle. Arc AC and arc AB are adjacent. Oh, I don't think we did this either. Did I show you that symbol yet? Okay, there's a symbol for circle. So you don't have to write out the word symbol, just draw the circle. Put a dot in the middle and then put the letter for the center. Remember, they're named by their centers, which is also not part of the circle. Who said wait? Okay,
What does that mean?
what does what mean?
Like the symbol.
Circle.
Circle and
Yeah. You could write out circle if you want, but that'll save you some hassles. All right, this will be fun. Ready? Give me a second to draw the picture. What?
well, couldn't you say, what's it called?
I don't know, you're
Or
talking.
arc FG, couldn't that go around
No.
that way in? So how do you know which way it goes in?
Great question. I'll see if I can get your question answered by someone else. Franny? John's question is, if I say arc FG, how do I know which arc FG I'm talking about? This one? Or this one?
Wouldn't it depend on if it was a major arc or a minor arc?
Okay, so Franny, name a minor arc up here.
If it was a minor arc, it would be FG,
That's one. Give me another one in the picture.
FR,
And?
RO,
And?
OG.
The original gangster?
Yes.
Cool. Okay, now name a major arc.
FG,
And how do you write FG going that way?
The FG.
Oh.
It's through.
I know.
Listen.
I know.
FSG.
F,
S.
no, not FSG.
FGO.
F.
GO. Like around. Is that what you're naming?
Well, that is a major arc, yes. You're talking about that one,
What are you
right?
talking about?
FOG.
We're trying to get the name of this guy.
Oh, so then you would say F.
That's gonna
or I
work
mean,
great in the video, by the way.
GR. No, how would you say that? GRO? No, because I wouldn't name the whole thing. Would you just say circles?
Huh?
FROG.
Yes, but we only need 3.
FOG.
So this arc has a number of names. You could call it, Franny?
Did you say FOG?
FOG would be one.
Could you do
FRG would be another.
No, because you have that endpoint.
GOF would be another. GRF would be another. Okay? All of those are the same arc. But when you go to a major arc, this one is a major arc, you need to switch to 3 letters. So that, what does the arc FOG mean? It means go from F to G, but when you go there, pass through the point O on the circle. Another major arc up there would be RGF. Raccoon, gopher, ferret.
I just realized what you meant about the video. Because they're not going to see your hand signals. So they're
Yeah,
just,
yeah, you got it. Yeah. So they'll be completely confused.
Yeah.
Of course, if they just came to class, they wouldn't have to worry about it.
So we put like a little curve on top of it.
You got it, yeah. Just like when you're doing segments, you put a segment over it, you're doing lines, you put a line over it. Now we're doing arcs, you put an arc over it. All right, where are the semicircles, Alex?
RG and GR.
You need 3 points.
Oh, ROG.
Okay, ROG would be this bottom one. The other one?
And RFG.
RFG. Good. Adjacent arcs, there's a whole bunch of them. RO and OG, GF and FR, or OR and RF. Not a big deal. What does that say? Oh, it's 10 o'clock. Natalie, question?
Are you just eyeballing it for like a minor arc to see if it's like less than 180?
I know that that's a minor arc because I know that this is a diameter and it's less than a semicircle, so it's got to be minor.
Okay.
All right, we good? All right, now we'll do some calculations. So I got that same picture, but now I know that angle RSO is 57 degrees. And notice it says angle RSO, not arc RSO. And FS is 8. Find the measure of GO and find the arc length of RO. Are we in pen mode here? I don't know. Anybody know when that siren goes off?
10 o'clock.
10 o'clock.
10 o'clock on?
It was the
First
first
Tuesday
Tuesday
of the
of
month.
First Tuesday of the month, correct?
Oh, I thought you meant like
Wait,
all
why?
like
Why does it go off every Tuesday?
Let you know that we're being attacked.
by the Russians.
Doesn't have to be the Russians.
Could be by the
Could be anybody.
Who is it?
It wouldn't be the Russians, but the good president.
Oh, yeah, because Trump is chill with the Russians.
All right, that's enough. We don't need to bring politics into this. I need a break from it. Okay,
You
my
just
pen-
voted this
year
my
was
pen's
the
not
reading
working.
from last year.
Think about that if you voted.
It
You can't
can't
ask.
who they voted for.
What if he doesn't want to tell you if you voted?
Then he would say, I'm not.
Okay.
I'm not.
I'm not gonna tell you.
How big is arc GO?
Unless you really hear what's right.
Simon?
It's 180 minus 57. So
Máquina de matemáticas, sí?
Sí, 123.
Sí.
123.
Sí.
Yes.
Sí, bueno. Sí. GO. That guy. That's 157, that's 123, because 180 minus 57, because RG is a diameter, and therefore the measurement of RGO is equal to the central angle. Good. Simon? How long is RO?
57. Oh no, never mind.
No, the arc measure of RO would be 57. You are correct, but I'd like to know how long is RO. If you were to go for a stroll around the giant circle.
Is it 57 over 360 times, and then you have to do the circumference? Or
Shall we start with a blank formula?
Sure.
Good call. You want to do C or 2 pi r?
2 pi r.
Okay, you're going to jump right into the 2 pi r. I like it.
So should we use that every time?
It's up to you. You could just put a capital C in there and then switch it over later.
Can we use d pi instead?
What's AM?
AM is 57.
57, good. And what's R?
R is 8.
Good. Plug and chug. And again, let's round to 2 decimal places. I don't care about an exact answer here. We'll just take a decimal.
So 7.96.
7.96. Natalie, yes?
Yeah. Oh, I was asking if you always wanted us to use approximate answers for the way.
If it doesn't say, you can give either one.
Alright, I got something.
I got 7.9.
Simon, 7.96 what?
Units.
Good. Since I didn't tell you the units, it doesn't say inches or centimeters, then you just use units as your units. That's going to be the biggest problem for people, is getting confused when you're supposed to find the arc measure versus when you're supposed to find the arc length. Okay. Any problems? Hot diggity. Nice. See, I used 2 decimal places this time. Yeah. All right, find the length of DA, of arc DA. Let's go with, what do you think, green?
Sure.
I don't know if it shows up very well. Oh, by the way, this 12 is the entire diameter. Which one's DA? The green one or the blue one? The blue one is correct. If I was whoop, I didn't even draw the green one correctly. If I was talking about the green one, what would I name it? Say again? DCA. I probably shouldn't have done that, but I was too lazy. I put in 2 pi r right away, but I probably should have just used d pi because I have the diameter. So now I take the diameter, divide it in half to get the radius, which is 6. But then when I plug it back in, I'm going to multiply it by 2 again, so I end up back where I started. It's not very efficient. Thank you for understanding. All right, what's the arc measure? Hey,
152?
why?
Because you do 180 minus 28.
Beautiful. Again, AC is a diameter. We can assume that it's a diameter. I'm not going to do something like this. Wow.
That was nice.
Hopefully I won't do that. Let me try that again. I'm not going to take a circle, draw that in there, and argue later that that's actually 179.99. Okay. you can assume that if it passes through the center and it looks like a diameter, it is a diameter. If it's not, I will make a point of telling you that it's not. But we can assume that that's a diameter. And so therefore, what'd you say, 152?
Yeah.
All right, so when we plug and chug, what do we get?
15.92.
Can somebody confirm?
Yes.
Beautiful, 15.92. Units.
Centimeters.
Centimeters. Just seeing who's paying attention, good job.
Wait, why would you have to, I don't get, like you said, you'd have to plug it back in again? If you reduce the radius?
Oh, yeah, because I had the diameter. My point being, I should have just done up here,
Yeah.
instead of plugging in that, I should have just done d pi. Because what I had to do is I took the diameter, divided, I have to get the radius, put the radius in there for r, but then I end up doubling it anyways. I get back to the diameter, so I just want a big circle. When I could have just put in d pi, plug in 12, I'm good to go.
Okay.